Hello students, coming to Java programming, academic year 2021, second BTech semester 2, R19 regulation JNTK Kakinada. And coming to unit 3 of this Java course, and we know that unit 3 consists of two chapters. Chapter 1 arrays in Java, chapter 2 inheritance, and we covered this chapter 1 arrays in Java in 5 videos, and currently we are seeing here video 3. And coming to the chapter 1 of unit 1 arrays, and this is the topic we are going to cover in this video, sorting of arrays. Here sorting means arrangement of a set or a group of elements into an order, that order may be ascending order or descending order. This order of arrangement of a set or a group of elements and stored in that array here, and we'll see this one clearly. And coming to the sorting of arrays, the sorting of arrays is often needed in many type of applications of arrays, and we use these arrays in real time to organize a group of similar type elements or to organize a group of or set of elements, and mainly using data structures. An array will be considered as one of the data structure familiar one and famous for organizing a similar type of or a group or set of an elements into one unit called array. And this sorting application, and we know that whenever we have a set of elements, for some situations we may try to arrange the elements or group of elements of this array into particular order, and that order of two may be type ascending order or descending order. And here we have one example real-time case, the preparation of examination results. The preparation of examination results, generally the students will get the result in form of grades, and here you may require to arrange the entries in order of grades acquired by the students, or in particular alphabetical order according to the alphabetical order, and we are arranging the grades of a students in particularly to announce the results of the particular situation. Then these are maybe the style like dictionary, using this alphabetical order style of arrangement of the words in dictionary. And the same way here, the arrays may be sorted in ascending order and descending order. This ascending order of an array elements nothing but for a given set of elements unordered, and we are getting this all these unordered elements of an array into a particular sorted array, and that too ascending means low value to high value. That means a low value to, we are arranging elements from low value to high value, high values. And whereas descending is completely contradict to this one, we are arranging that elements in high order to low value order. High value to low value, we are arranging elements, that the order is sorting order is called descending order. And there are several methods or several type of sorting methods for arranging, getting particular order of the given set of elements of an array. And these are the familiar ones: bubble sort, selection sort, insertion sort, and quicksort. And these sorting methods are already covered in the semester 1 data structures course, and we will see once again, and I will remind you the process of these sorting algorithms and how arrays are using to arrange these type of different techniques methods applying on the array elements to make those elements into order, either it may be ascending order or descending order. And coming to the first one, bubble sort, here bubble sort, and the technique of this bubble sort is, and here where this based on the size of an array or elements, it's going to apply iterations, and we call those iterations as pass 1, pass 2, pass 3, like that. And here the basic methodology of this bubble sort is comparing side by side elements, just like consider A is an array of elements having some size n elements, and this A of 0 nothing but first element in the array, 0 indexed element of an array, and comparing the next side element of one index element, and both are comparing, and then according to the order we are going to be arranged, for example ascending order, and while we are comparing this one, keeping the lower value as the first position in the array. That is the process we are going to apply in the bubble sort. And the likewise, A of 1 is compared with A of 2, and A of 2 is compared with the side element of the side element left to right is A of 3. And doing the same upon to the end of the array. And this is considered as one pass. And again, we come back to the starting array and do the same process. And I will show you this process. And this process will repeat for n minus 1 times. When the array has n elements, and this process repeats n minus 1 times to make arrange of the elements into a particular order using bubble sort. Consider an example here. A is an array. A is an array. And these are the elements, example elements. And as I told you, this is the index 0, 1, 0 element, index 1 element. First compare these two. And 30, 52. When 30 is smaller than 52, and we are going to arrange these elements in ascending order, lower to higher value. So 30 compared with 52 is a lower value and 50 is a higher value. Here, no need to get this swap operation to make that arrange of ascending order. And we will leave it this one. And again, we shift to this one. We will compare this one index element with two index element, that is 52 and 29. 52 and 29. And here 52 is higher value, 29 is lower value. And this lower should be come first. Why? Because we are arranging the elements in ascending order. So 21 should be bring to the previous position. So both swapping here applied. 21 will copied into the one index of an array, 52 copied into the two index of an array, like this. Then after that, side by side element, this one, 52, 87 will compare, and no need swap operation here. And 63, right, 87, 63 will compare. And here 87 is larger, 63 is smaller. So we will swap here. Swapping is done for making this order of elements. Like this, we do the same. 27, 87, and 19, 18, and 54, 87. And by doing this one, finally, at the end of pass 1, this is pass 1. But at the end of this pass 1, the largest among all the elements, the largest of among all the elements given in array, and the highest value should come to the high index of an array. So what is the index of this position in array? 1. And this is n minus 1. And the highest element, right, because we are arranging these elements into ascending order, lower to higher value. Though whatever the highest value of among all these elements should bring to this highest index of the array. This is pass 1. And in pass 2, we will go back to again starting of array, and we will compare both these two. And these two required a requirement 29 should come first, and 29 is this first, though no need to swap here. Swapping is done. 30 compared with 29. So next one, 30, 52. 32, 52 will compare, and 30 is smaller, no swapping. And 52, 63 compare. 52, 63 again lower value, upper value, greater value, so no swapping needed. But whenever this 63 and 27, this one, 63 and 27, 63 is larger one, 27 is a smaller one. Here should be swapping needed, and to make arrangement of this 27 and 63. Both are swapped here. Right, got it? And pass 2 continues. And like that 1963 and 53, 54 like this one, and 54, 63. And here this swapping arrangement. After pass 2, a second iteration, the second largest element come to this position of the array. Like this, we will repeat this process until the array would be sorted in a ascending order. And pass 3, if you do the steps like this when comparing, and just reminding you already know that process of applying bubble sort. And after pass 3, the third biggest element will come to this position. Got it? And after this pass 4 apply, the next largest element come to this position. Then again pass 5. In this pass 5, the next element should come to this one. This color indication clearly showing you that the elements, the largest of remaining elements come to this position. Like this, we are sorting element from right to left. And after pass 6, and we arrange all the elements like this, this one, 29 will come to this position. And after pass 7, 19, 27 will fix like this. So this is the final sorted array of given set of elements into ascending order. Here, this is the process of applying bubble sort. And I will show you one graphical visualization of this bubble sort. See here. So this is an example elements given. During the first pass, first these two elements are compared, next these two, like this. And after the first pass, the elements will be partially sorted like this. And applying the second pass, we will start again these two, next these two, like that. So this way we can arrange the elements, either it may ascending order, descending order, according to the situation. The bubble sort applies the techniques to make the arrangement of the array elements nothing but a group or a set of similar type elements. And here coming to the time complexity of the bubble sort is order of n square. Coming to the second type of sorting method is selection sort. This one is already, you know that. Once again, I'm reminding you, consider an array with n elements. Selection sort works based on the technique like, first find the smallest value among the given all the elements in the array. Smallest value in the array and place it in the first position. This is the first step. And second smallest value in the array and place in the second position. And repeat this process until the entire array is sorted. This is the process is called selection based sorting algorithm. Selection based. And go to example of this one. So consider this as a given array, set of elements. Consider this as an array. This one is array. And see, you have to understood first, not these sorting methods, and I'm not here the cases, understanding of these sorting methods, how these arrays are used in these applications of sorting, of how to making a group of elements into an array, and how these elements are organizing for arranging in a sorting order by different techniques, and how these arrays are used and how arrays are useful for these sorting applications, and applying operation of sorting method algorithms on group of elements called array. So you first understand that one. So first among these elements, what is the smallest value is 9, and bring that 9 to the starting position, then apply 9 and 39 swapping. This is pass 1, first iteration. So 9 is the smallest value, bring into the first position of array, and at this 0 index is 39. 39 will go back to 9th position. Swapping applied, right? And this is the right now current array element positions. And in these elements, what is the next smallest element? What is the next smallest element is 18. And this 18 should bring to the position, second index position, that is this one. So 18 and 39 will swap. So see here in this second pass, 18 will come to here and 39 will go to this position, right? These two positions are sorted now. And in the third iteration, we see here the position of smallest element we are finding. First is the 9 is the index 1, and 18 windows array index 7. And next smallest element is 27. So here it is 27 at 5th index of an array. So take this one position 5, and this should be bring to the third position, that is here. So here it is the that 81 there, 27 and 81 will swap. And if you observe 27 here, 81 here, and these three are sorted now. And now for this fourth pass, find the next smallest element after this one among these elements. That it is 39. That it is 39. Keep this element as it is here. No need of saving, right? So here that is the position of getting. Next one. The next smallest element at index it is 45. That it is 45. 45 should come to this position, and 90 and 45 will swap each other. So 45 will come to this position and 90 will go to this position. So till this one is sorted. And among, check this one. 72 is the smallest of this one. So swap with 81 at this position. So 72 here, 81 here. And this up to this one sorted. And among this, 81 is smaller, keep as it is. So finally, after this pass, and all these elements are sorted out. And all these elements in sorted order, right? Got it? This is the process of applying selection sort. And we'll see another example like this. Take this diagram. Here the first pass here, among all these elements, 13 is the smallest one. So bring this 13 to first position, then swap with this position. So 13 will got it here. What is the second one? Up to this one sorted, and remaining elements check for the smallest 29. So 29 will come to this position. So up to this one is sorted now, and check among this which one is the smallest, 36. So get swapped with this position 98, and this one up to this one sorted. And among this 51 is smallest, and bring to that position. Up to this one is array is sorted, and among this again what is the smallest, 52, and 52 swap with this position, and till this one is array sorted, right? Sorted array. And among these which one is the smallest, 66 is smallest, but no swapping. 66 is appropriate in that position, correct in position, and no need to swap apply here. Then again, among this 72 is smaller, this one and 2, no swapping, 87 is smallest, then apply. So this is the sorting completed, and all the elements are sorted in order, ascending order. You got it? I hope you understand the process well, because you're already familiar with these topics of arrangement of elements using different sorting methods of a given elements in array. And coming to the insertion sort, I'm just reminding you the process here once again. Insertion sort works as follows. The array of values to be sorted is divided into two sets. That is the first one set that is sorted values, and another that contains unsorted values. Right? The first it takes unsorted set elements for sorting, that is nothing but an array of group of elements here. And consider an array of integers given below. We will sort the values in arranging using insertion sort. So first we consider that, so these are the given set of elements of an array. Here it is an array consideration. And all these array elements we are going to arrange in ascending order. And we will first have this process saying insertion sort. First, A of 0 is the only element in the sorted list. From left side, we are making the elements into sorted order, and the right side elements are we are making into the unsorted order and trying to make all those values into sorted. So this is the first element that not sorted here, and we consider that this one is a sorted one, and we will take one by one element into this part of sorted array and comparing each other. And when we compare this element with this 39, and 9 should be the smaller, so bring that 9 into the first position, and 39 will swap with 9, swapping both. So here till this one, up to this one is sorted now, and this is sorted array, sorted, and the remaining part here it is unsorted. And we divide this one like this, and applying insertion sort like this, sorted and unsorted. Again, we will take 45 now from this unsorted element, and we compare 45 first with 9 as it is satisfied. When we compare 49 with 39 as it is order satisfied, 39 lesser with compared with 45. So 39 is keeping that position again and 45, and we will take after this. This is pass 1, and in pass 2, as I told you, this 45 first compared with 9 as it is smaller value 9, 39 is also smaller. So till this one is sorted and this one is unsorted. And take the 63 element, compare 63 with 9, 39 and 45 as it is satisfied. So until this one is sorted and this one is not sorted, this part. And take 18, 18 compared with 9 as it is satisfied, but 18 compared with 39 is not satisfied, right? And swap both. So 18 will come to here and 39 will at this position. 39 and 45 compared. So 39 should come to here and 45 will go to this position, 45. Now the sorted array is not completed. Still another element is there, 63. 45 compared with 63. So 63 is greater. So 45 will come to this position and 63 will come to this position. This is. So till this one is sorted and remaining is not sorted. And again take 81. 81 compared with 9, it is satisfied. With 18 satisfied, 39. Order satisfied, 45, 81. As order preserved, 45 is smaller, 81 is greater. 63 is smaller, 81 is greater. So this one is sorted. Like that, we are taking elements to order arrangement of elements into an order. This way you can apply this one. Go to the simple example of here. So first take 54 and 54, 26, swap each other, and 93 satisfied, and 17 should come to this position until this one is satisfied. So we are taking every element. For example, 77 we are taking, compare with all the elements until this part should sort into ascending order. And taking 31 element to compare with this sorted array and find the position of this one into the sorted array to get all these elements with sorted order. And apply this process to get sort of these array elements into ascending order using insertion sort method. And coming to the time complexity of this insertion sort algorithm, and basically it's having difference between among average and worst case. It gives order of n square time complexity, but as in a best case, it gives order of n, where n is the number of elements, nothing but an array size, where n is nothing but here array size, the number of elements in that array. And based on that comparisons, we are going to apply comparisons and swapping. So to make arrangement of these elements using insertion sort. And coming to the quicksort, and we know the process very well. Quicksort works, and as its name saying, it sorts the element very quickly. And here one the best first starting process is select an element as pivot. Select an element as pivot from the array elements. And rearrange the elements in the array in such a way that all elements that are less than to the pivot appear before the pivot, and all the greater and all the elements greater than the pivot element come after it. Equals in U. So it means here it is the process of dividing the array into two parts when we are selecting pivot, and that is the first step in the quicksort. And the second process is comparing the remaining elements of the array with pivot and making a proper arrangement and dividing that array into two parts with this pivot element swapping at the end of one iteration. And the elements that are left side to pivot element or smaller to pivot, the elements after the pivot position in the array is greater than to the pivot element. So while doing like this, applying again the quicksort from the left side to pivot and right side subarray to pivot, we get the element arrangement order. And here, after a such partitioning the array, like applying the process of quicksort, the pivot is placed in its final position, and this is called partition operation. And after this partition operation only, the pivot will come into the particular position of an array. There, the position of that pivot element, and before the pivot element are smaller to pivot, and after the position pivot elements are greater to pivot elements. And recursively sort the two subarrays, whatever the partition we applied based on the pivot element, and apply the same process for the subarrays of pivot, subarrays of an element, and here the elements get maybe ordered into the arrangement, or either it may be ascending order, descending order. Okay, coming to this example of this quick search. So here these are the array elements taken, and this is the pivot element. First element is the best choice to select the first element as pivot, and there are some alternative methods also there to select pivot last as an last element as a pivot, random element, mid element as a pivot. There are many type of logics there. The best choice is selecting the first element as a pivot, and here we take left mark and right mark, and we compare the elements from left mark side, and this element, left side mark element, always be less than 2 pivot. Then only this left mark index will go increment here. It will go increment here. And wherever coming to this right side mark index elements, always be greater than 2 pivot element. Then only this right mark index should go decrement this, and it travels to this direction, right to left direction, and this left mark travels from left to right mark. And we, when this two, applying the comparison like this, 26 is compared with 54 is smaller, so increment applied, and the index pointer come to this position element for comparison. 93, 54 is greater, and stop the process here and go to right mark, and it is 20 compared with 54. We are expecting greater, but 20 is smaller, so it stop the process. And here, what will we do is, here it is condition satisfied, and here also the process stop, and here also the process comparison stop, and both the elements are swapped with each other. So 20 will swap to this position, and 93 will swap to this position. So 20 will come to here, 93 come to here. Again 20 compared with 54, it is satisfied. So now continue moving left mark and right mark. When these two cross each other, until they cross, when they cross and stopping the process, then swap this pivot element with right mark position. Then and taking that one, left side of all elements of this pivot is less than 2 pivot, and right side of elements, all the pivot elements greater than 2 pivot. So likewise, we divide the given array set of elements into two subarrays, as we said in the previous slide. We can divide this, the given set of elements, into two subarrays, and the pivot element where it is swapped with this right mark index element, then it divides the array into two sub-arrays. This the process is called partition operation. And we apply the same process for the left sub-array and right sub-array of compared with pivot. So then automatically it arranges the elements in sorting order quickly. So coming to the time complexity of this quicksort algorithm, again it has both the cases, average and best case, and we will give n log n. This is the best time complexity, n log n. And worst case complexity of this quicksort is order of n square. Order of n square. Got it? And so we covered all the type of sorting algorithms till now, and coming to this position. Yeah, right. So we covered all these 4 types of sorting algorithms, and I just given a recap to these sorting methods that already covered. You are very familiar with this data structure sorting methodologies. And once again, I'm reminding you that these are the different type of applications of sorting and arrays, and how these arrays are helpful in these applications to organize a set of elements in applying operations on elements of the array. And okay, then coming to the references here, these are the references, and thank you.